So for this example, we have the polynomial h of x is 3x to the seventh plus some lower power terms, and we need to know what the end behavior of the graph is. So just like the last problem, we're just going to look at the highest power term. And namely, we want to look at the parent function for this highest power term. So that's going to be y equals x to the seventh power, since the end behavior of this parent function is going to behave just like 3x to the seventh plus all these lower terms. And so if we look at our parent functions again, just to remind ourselves, when we have x to some odd power, it's going to behave just like a cubic polynomial. If it was negative, which we'll need in a later problem, the y values get reflected. So since it looks like a cubic, we can just redraw it for our particular problem and go through this exercise. So ours will look something like a cubic, roughly something like that. And what we can see is that as x gets very large in the positive direction, so as x approaches infinity, the function h of x, you can see, goes up to bigger and bigger positive values. So the function will approach positive infinity. Now, as the function approaches bigger and bigger negative values, so as it goes to negative infinity, you can see, just based off the graph of the parent function, that the function gets more and more negative. So it's going to approach negative infinity. Now, you don't always have to rely on the parent functions. You can also just plug in bigger and bigger numbers and see what happens. So as you plug in, let's say, a large positive number like a million to the seventh power is a very large positive number. Whereas when you plug in a negative high value number like minus infinity, it's still going to be a large value, but in this case it'll be negative since you're going to have that number multiplied 7 times. And so 6 of those, the negatives are going to cancel out since they can pair up. But you're always going to be left with one extra at the end, which will reflect it down and make the y value negative. So as the x values get more and more negative, the y value will get bigger and bigger in the negative direction. So if you forget how to think about these with parent functions, then you can always just plug in values. But to get a very deep understanding of this, it's probably better to think about it with these parent functions. So let's do a couple more examples. And in this one, we have a polynomial p of x. And again, we're just going to look at this highest power term here. So in this one, we have minus 9x to the ninth. So we need to know the parent function for x to the ninth, but it's also negative. So it's just like the cubic. So let me draw these in. So if we had x to the ninth, it would look just like our previous example. Let me redraw that. But now that we have this negative sign, basically if the y values were negative, they are now positive. And if they were positive, now they're negative. So we need to consider this parent function for minus x to the ninth, this blue curve right here. And as x approaches infinity, notice that the function starts to get more and more negative. So we can say that p of x approaches minus infinity. And again, I encourage you, plug in big x values and confirm this for yourself. If you plug in a million or even something like 1,000, when you raise that to the ninth power, it becomes a huge value, but then you're going to take the opposite of that. So it would become a very large positive value, but then you take the opposite of that, and so it will be a very large negative value. Likewise, when you plug in a very large negative number, you get a positive number. Since if you plug in, let's say, minus a million, you raise that to the ninth power, since you're multiplying it 9 times, 8 of those cancel out, but then you'll have one negative left. And so minus a million to the ninth is a negative number, but then you're going to take the opposite of that negative number, and it becomes positive. So if you're unsure about the parent functions, just plug in those very large negative numbers. Let's do one last question. In this one, our dominant term here is this minus 5 times x to the sixth. So we need to look at the parent function for x to the sixth, but then we're going to make it negative. So let's quickly sketch that. So if we have, let's say just y equals x to the sixth, so that's going to look like a parabola. So something roughly like that. And then when we make it negative, basically when the y values are positive, now they're going to be the opposite. So that will be for all of them. So it's going to reflect it about the x-axis. So it's going to look something like that. And so as x gets larger and larger, or as x gets more and more negative, in both cases, the function p of x is going to approach negative infinity. So looking at our multiple choice, it should be negative infinity for our function p of x in both cases. So this one is mixed, negative and positive, and this one is negative in both. So it looks to be choice letter C. And I realize I did not mark the multiple choice for the last one. So in this case, as x gets more and more positive, it goes to negative infinity, so it can't be A or D. And as x gets more and more negative, it goes to positive infinity. So that should be choice letter B.